Hello everyone, myself Srini. I'm a telco solution architect with AWS. We are going to look at the smart defect detection manufacturing industries. Today, what we are going to do is we had a customer by name Jabal here. This is a US-based global manufacturing industry. So Jabal came to us approaching for a solution where they wanted to address a problem, right? Today, their racking and stacking are human intensive. They are trying to have a issue that in a quality inspection line in the manufacturing process, they are hitting a target of 70 instead of meeting their actual target set at 90 units per day because the qualities are not detected at the right appropriate time actually. So what was the solution that they were expecting is, can we go for a real-time defect detection in the manufacturing process so that we will be able to identify the defect at the early stage of the production that can avoid the going back and forth of a production line to avoid the delay in producing more units there, right? So what AWS along with its partner, Accenture as a global system integrator here brought in the Verizon story along with us to build a private 5G network that's going to provide them an optimal production environment with a performance improvement there. So here what we are doing is basically we are trying to build a private 5G with a computer vision. So computer vision objective is to identify the fault that's happening in the production line at the near real-time scenario. Here you see a snowball edge here. Snowball edge is basically the edge computing device that's placed at the Jabal's industrial location where it can withstand all the rugged environment of the industries. You see the 5G wireless offered from Verizon, and this is going to give you the required level of bandwidth and latency requirement for processing in real time, the video streams getting from the cameras. So today what we are going to do is we have a computer vision algorithm that's deployed in the snowball edge running in the factory. And the streams from the camera, real-time streams from the 5G camera are getting streamed into the CV application that's running on the edge computing device. And this processes and gives you the output, whether there's a defect or no defect in the complete manufacturing process. So we are going to see the demo of the system here. So the camera is streaming the entire image. We have the Euler algorithm version 8 deployed here, where you have two objects. This object and this specific objects are getting detected in the manufacturing process. This specific object is classified as misplaced. That means that this is the defected one, and there is no defect in this particular version of the interface there. So I'm going to show you how this is in real time happening. So this is going to be plugged in rightly there. So you will see that the detection is going to be green, turning green, right? So basically, you see a placed option there. That means that there is no defect now, and this is completely is what the Jabal customer wanted, right? This information is displayed on the dashboards here. You see the count of display here. Basically, either it will be a bad or a good count, right? Depending on the detection mechanisms. So here you see the performance of the algorithm on the edge. This algorithm is a classification algorithm, and this one is the localization category. So localization and classification of the defect is happening all in real time. You can see that it's happening in millisecond time frame. This is what the customer wanted. And this solution has provided a performance improvement of 30%. That means they were able to reach 70 units to 90 units production capacity. And this is a happy customer, Jabal. It's a real production in Florida. They are industrial setups. Thank you, everyone.